Welcome to Chapter 6, Statistical Quality Control. This is the second chapter of our quality management chapters. In Chapter 5, hopefully you remember that, we studied Total Quality Management, or TQM, and at the end of that chapter, we learned how to calculate reliability for series and parallel systems. So in this chapter, we're going to talk about control charts and SQC. So this is the list of the items that we will learn in this chapter. The most important topic that we'll be talking about will be control charts. So those four different types of charts that you see here: X bar chart, R chart, P chart, and C chart will be discussed. And in the second video, I'll show you how to do the first two, X bar chart and R charts, along with the other important topics that we'll be discussing today. So what is SQC, or Statistical Quality Control? It's actually a toolbox. It's like a set of tools, obviously a set of statistical tools that quality managers and quality professionals use. So it's not just one method or one tool, it's really a variety of tools used by quality professionals. So these are the three categories of SQC. Number two that you see here, descriptive statistics. This is something that all of you learn in your business stats and in your other courses, like mean, standard deviation. Then number one is statistical process control, or SPC. This is mainly what we'll be doing in this chapter. We pick one sample of the product, we inspect that, and then we decide whether or not the process is functioning properly. So we'll be talking about that in detail today. And then there's number three, acceptance sampling, that we don't really cover in this course, even though it is part of your textbook. It's basically inspecting one specific batch of goods to determine whether or not that batch has to be rejected. So again, our focus will be on number one, statistical process control, or SPC. So just a very quick review of the things that you learn in your business stats 227, the meaning of the mean, standard deviation, data shape or distribution, and also range is something, I don't know whether you remember the meaning of the range, the difference between the highest and the lowest in the data set. We'll be using that one in this course as well. So normal distribution, the one on the left hand side, I hope you remember that. Here you see two normal distribution, two symmetric bell-shaped normal distribution. They both have the same mean, but the standard deviation is different here, obviously. And then on the right hand side, you see one symmetric distribution, the brownish one, and then you see a skewed distribution, right? So here the mean is going to be different, even though the standard deviation might be almost the same. And then one of the properties of the normal distribution that hopefully you remember from your stats course, and we need that a lot in this chapter, is the fact that for normal distribution, always 95.44% of the observations fall in this range, mu, which is the mean, plus and minus 2 sigmas. So that's one of the properties. Always this percentage of observations fall in between this range. And then if you expand that confidence interval, so instead of mu plus and minus 2 sigma, if you focus on mu plus and minus 3 sigmas, then you'll get an increased percentage of 99.7% of observations. Why are those percentages important? You'll see that in this chapter, but actually if you subtract 1 from these percentages, so 1 minus 95.44 and 1 minus 99.74, so that will give you what we call type 1 error. So the type 1 error for plus and minus 3 sigmas will be a very, very small percentage, which is less than 1%. For this one, it will be almost like 4.5%. And the last slide that I'll be talking about in the first video is variation. What is variation? Variation always exists in processes, and it leads to inconsistency in your product or service that you're offering. So always businesses try to minimize and mitigate variation. There are two types of variation. The first one is common or random. That's the one that always exists and we can't really do anything about. So it's actually sort of unavoidable, always exists. Those are the tiny variations in the volume or weight or other dimensions of the product. So think of one bottling operation, and always there's going to be a slight change in the actual volume. So sometimes if that variation is small, we refer to that as common or random, and we say we can't do anything about it. But if we have what we call an assignable cause of variation, so those are variations that cannot be ignored, and actually we have to do something about. We say it's assignable because we have to assign it to a specific cause. That cause can be employee training or something wrong with your machines, and etc. So in the next video we will learn how to do an X bar chart and R chart.